Hi there, welcome back to the channel. Welcome to a new project. This one again sponsored by PCBWay, and this is sort of a version 2 of a project that I did recently. The JFET booster, if you recall. These were the little boards, and I built up the booster. I've actually got a couple of these already installed in some friends' guitars, and I was really criticized for not playing guitar the last time. I'm sorry, I didn't want to scare you guys off. I might do it this time because what I've done is I decided to do a new version. This version, much to the horror of many of you, is really a smaller version of the boards. Much smaller version of the boards, really. And especially of the components that are going to be used. This is an SMD version. Now, why did I do that? Well, fitting this into the inside of a guitar can prove a little bit challenging, as I found with one or two of the guitars that friends of mine wanted me to install them in. And I told them to wait a little while, I'll come up with a better solution, and this is the one that I came up with. It's not so much the size of the board. If you see the boards, well, I guess they are different sizes, but it's not that big a difference. The main difference is the size of the components that are going to go on here. The actual PCB itself fits quite easily into the guitar, but the height of the components can be an issue. Even when I solder this all the way down and replace these trim pots with fixed resistors. So I went ahead and designed an SMD version. And fortunately, the JFET that I use here, the J201, actually does exist in a SMD version. I got these from Mauser. And as you can see, it's an interfet part, JFET, JFET N channel minus 40 volts. Where's the, there we go, SMP J201. There's also an MMBF J201, if I'm not mistaken. They're the same. And I decided to order these guys. I've got, what is it, about 15, 20 of them. These things are so small, I must admit. This is a little bit taxing. And a lot of you have complained in the past that you don't play around with SMD parts because, well, the eyesight starts suffering somewhat. And I must admit, I suffer from the same issues, but I decided to get it anyway because I wanted to make sure that these things go into the guitars and fit well. And I've also got a little device here that helps me, which is this microscope. And it really does make things easier to solder on here. I did a review on this recently, and I must admit this thing's come in really, really handy with things like this, because suddenly even my eyes can see some of the little detail on there. So what I'm going to do now is I'm going to populate this board. I've got all the components. They're very simple: capacitors, resistors, and of course the JFET that I've just shown you. I'm not going to bore you with the soldering. It can be a little bit challenging, but with a little bit of practice, you get there. And then I'm going to connect this up, and I'll be showing you some of the results of this on the scope and how we set it up and what happens when we make adjustments on there to get the different characteristics that we can get out of this thing. We can get this thing to sort of sound like a tube front end, or we can get this as a clean buffer depending on what exactly you want. In the one case we get less gain, in the other case we get more gain, and we will go through that and experiment with it and see what's the best setup depending on what sort of needs the guitarist has. Next time you see this, it'll have thingies on it. Very small thingies, but thingies nevertheless. And here it is. And it's still got a big blue thingy. But what I wanted to do here is I want to set this up for different positions or different biasing to give us different characteristics, and I'll be showing you that on the scope in a few minutes. But first of all, let me tell you what I found with this JFET. This little tester that I've got to measure the pinch off voltage and the Idss of the JFET certainly doesn't accommodate an SMD part. So I had to solder it, or solder that component onto these loose wires, which then plugged into there. But it allowed me to do exactly the same thing as I did before. On the one setting, I could measure the pinch off voltage, and on the other one, I could measure the Idss. And the results that I got were very common, very similar really to what I expected from a J201. This is the result of my testing for the particular J201 that I've got in that board at the moment. I tested a couple of others and they're very, very close. Strangely enough, they are pretty close. But the one I've got in there is giving me a pinch of voltage of 0.827 volts and Idss of 0.73 milliamps. Pretty good. So what do? I entered that into the Fetzer Valve website, which I mentioned in the last video. And what they tell me to use for the drain and the source resistors are these values. A source resistor of 940 ohms, a drain resistor of 9057 ohms. The gain should be about 4.8. The gain in decibels is 13.7 dB, and the drain voltage would come out to about 7.3 volts. This means that I could probably use quite comfortably a 1K resistor over here. That shouldn't be an issue. Probably 10K over here, and we would get close. But what I decided to do was to use a 1K resistor over here. This is the source resistor, and because I don't particularly want to use that source capacitor, the bypass cap, none of my friends really want that, I put another one in here in parallel, which is 15K, and in parallel with the 1K it actually comes out to 940, damn close to 940 ohms. So we're actually very, very close to the theoretically ideal value for that resistor. And the only difference is that if I wanted to put a capacitor, I could have taken this resistor, the second resistor, I could have piggybacked it on top of that one, put the two in parallel, one on top of the other. I've done this before, they work very well, and then I'd have that slot open for the capacitor. But because I don't need the capacitor, that's it, I'm not using it there. I've got my 220 picofarad capacitor over here. This is the one from the gate to ground. I've got my 33K over here, the resistance between the input and the gate. I've got the 1 meg over here. I've got this capacitor here is, what is it? I've actually used 0.47, if I'm not mistaken, on both the input and the output, just because it makes it easier to use the same components. Not critical. And of course the JFET over there. I've got a tantalum SMD over here, 10 microfarads. That's the one that smooths the power coming in to reduce any noise. And of course I've got this trim pot over here which allows me to adjust it. I'm ultimately going to set this to what I want. We'll determine that on the scope, and then I will replace this with a fixed resistor. So let me set this up, and I've already done some connecting and I'll show you why. To test this in the guitar is a bit of a problem. So I've connected a jack to the output. That's my signal out. Here's my jack. I can simply take this and connect it to the input of my amplifier. And then what I'm going to do is, to test it, I'm going to use a guitar on here. So I've got this jack coming in here, and I've used a stereo jack. In this case, I've connected the negative of the battery. There's my battery clip. The positive goes to the positive there. The negative goes to the middle pin of the stereo jack. And then, of course, the signal is the top end, the tip, and the ground of the signal is the ring. So when I put this in, this is a mono jack, which is what you'd use in a guitar. Well, from the guitar to the amplifier, it shorts out those two and it makes the ground. I've actually used this on the input. It's incorrect. This is usually going to be on the output, because that's the one that will use the stereo jack. The input won't have a jack. It'll go straight to the output of the pickups, where you normally would go to the output jack. But I'm going to connect this up. I'm going to connect up a signal to the input. I'm going to connect the scope to the output. We'll be able to follow that, and we'll be able to see what kind of signal and what kind of gain we're getting, and how this RD, how that adjusts the gain, and what kind of characteristics we get from the little buffer. I'll tell you right now, the range of gain is enormous by adjusting this, and also where it's going to clip. So we'll be able to play with that and see which is the best position for the individual needs. Because they do vary. I mean, every guitarist is different, and what they want from their guitar is different. So let me get that set up and I'll show you. All right, folks, this is all set up to fine-tune the circuit over here. I've actually changed the negative of the battery to the output jack, so to that middle of the stereo output jack. This is exactly as it would be in a guitar. This would be the jack on the guitar going to your amplifier. And this jack here is just for me to test the system with, because I'm not going to plug this into the guitar just yet, or my guitar anyway. I'll be using this almost as a pedal. So I'll plug the guitar in here. This will go to the amp. We have the same effect. And if I check the supply line, which is this guy over here, As you can see, I've got 0 volts. I've got the negative of the meter connected to the ground line over there. If I plug this in, 9 volts. It's a very fresh battery, 9.4 volts. Okay, good. So this effectively is the way it would be set up if it's in your guitar and you've plugged a cable into there and plug this into the amplifier. Now, what are we going to do? Well, first of all, because I've got all the resistors there perfectly aligned to the theoretical ones, 940 ohms, I need to set that up to 7.3 volts according to the calculations I've done. So what I will do is I'll put this over here, and as you can see, I've cheated. I've already done that, but you can see that what I can do here is I can adjust this quite a lot. I can go all the way to the supply line, which is stupid because it'll just clip very, very early, or I can just make it go all the way down, and what I'm doing here is increasing and decreasing the drain resistor, RD, and this is having the effect of changing the bias point, or really the output voltage point. I can go quite far down, almost to the ground, but I don't want to do that because I want this, let's leave it at 7.3, about there. Let me just check what the resistor is. I'm not sure that I can measure this in line. Maybe I can. Let's see if I can measure what that resistor is. Let me disconnect the power. 8.6K. Now, the calculations gave us 9 point something. So it's not far off, 8.8, 8.9. This is very, very close. Very close. But it doesn't matter. Anyway, that battery is not 9 volts, it's 9.3. So everything is sort of, well, slightly distorted and not very precise. It's not meant to be. These FETs have great variations between them. Now what I'm going to do is I'm going to feed a 1 kilohertz signal into the input. 1 kilohertz signal going in here. I'll leave the meter there. And now I'm going to connect the scope to the output. And we are going to look at the scope as well as the adjustments that I'm going to make here and see what we can change this to. Right, there we go. The signal coming in is exactly 100 millivolts RMS. And as we can see at the output on the scope, we've got 425. So we've got a gain of 4.2. It's not exactly 4.8, which was the predicted amount on that calculation, but it's pretty close. It's pretty close. And it's a very clean sine wave, which means that if we input 100 millivolts in there, we will get, well, 4 point something times greater with no distortion. Now, what happens if I increase this? I'm going to increase this from 100 millivolts to 200 millivolts, still very clean. 300 millivolts, still very clean. I'm going to drop the scope range. Now let's take it to 400, 500, that's 500. That's 400, that's 500. Now in 500 you can see you're starting to get a rounding off at the top. See that? That is sort of the valve or the tube effect that you're going to expect, but it goes further and then it gets to real clipping. It's clipping at the top, but watch this. If I do that, you're actually reaching the supply rail. If I change the scope to DC, you'd see that that is way up at the top, right near the 9 volt rail, which is why you're getting the clipping. Now, what can I do to improve that or to change that? Now, let me explain something first. There are friends of mine who want this exactly. They want this to be set exactly as it is, like this, right? What they want is they want to be able to control the distortion that this thing is going to introduce with the volume control of the guitar itself. So the whole point of minimizing the distortion is really in their hands. They can just drop the volume of the guitar if they don't want as much gain. This 4 point times gain is not that much, but it is noticeable. It makes the whole guitar a lot hotter, as it were. But they want to be able to control it with the volume control so that if they do want distortion, they put the volume on max and they get this. And they can actually get pretty crunchy distortion up there on the one half of the waveform. And that's the effect they want. So they're basically creating distortion before the actual preamp of the guitar. That's what you use pedals for, right? If you're using pedals, if you're using a crunch pedal or distortion pedal, you can do that. And this would be an asymmetrical distortion, which is what some of them desire. Again, you know, what you like is what you like, not for me to comment. You can see that there is already distortion there because the top part of the waveform is it's a lot rounder than the bottom end, okay? Now, other guys want this thing to be just a straight, clean booster and buffer. Now watch this. If I take this down, the 7.2 volts, if I take this down to say 2/3 of the supply, say 6 volts, okay? Look what's happening to the waveform. 6 volts, okay? Now what you've got, let me drop the scope again. Now what you've got is you've got this rounded distortion, but I can go much higher. I'm going to go to 500, 600. Now the distortion is happening on top and bottom. You see, that's giving you a different type of distortion. It's giving you symmetrical distortion on the top and the bottom of the waveform. And if I want to get it perfectly aligned, I can go one step further. I can actually do this. Other way. See that? Now that's got perfectly symmetrical distortion, top and bottom, and it's rounded distortion. It's not sharp. It's not, you know, shrilly. It's smooth distortion, or smoother. And you can see as I increase the amplitude of the signal. So if someone's playing guitar and they're playing this very low, they'll get a very clean signal. If they hot it up, really hit it, you'll get this, right? So you see now that there, for example, is a 300 millivolts, perfectly clean signal. The other thing is, look at the gain. That gain, that value out there is 2.26 volts for 300 millivolt. I'll put it back to 100, makes the calculations easier. Change the scope. That is 7.6 times. That's a 764 millivolt output. 7.6 times. That's massive gain, really, for you know, preamp gain on there. So what you basically got is a volume boost pedal over here. And what I like to do for the smooth gain, I like to leave it at 2/3. It's just me. So battery's 9 volts. I leave it at 6. I get 7 times gain. Okay, that's a lot of gain. What I'm going to do now is I can measure the resistor here. And I can do that like I did before. I'll just remove this. And I'm going to check the resistor or the resistance of that trimmer. 14.4K. That's a 15K resistor right there. Okay. What I'm going to do to show you the result, I'm going to test this with my guitar and horrify you guys with my playing, is I'm going to put it back up to where we were, which is 7.3 volts. Switch it on. Up to 7.3 volts because I want to test it on my guitar, and I prefer lower gain. I prefer the tubey sound. I'll be quite honest with you, I can't even really discern much, and I think you'll be able to discern even less, because I'll be recording this, you know, from the output of the amplifier through the microphone, all that sort of thing. But I'll play it without it, and then I'll play something with it. It'll be a few chords just to show you the result, and then you can make up your mind. The point is, this thing is perfectly tunable. It's a programmable JFET booster buffer with a possibility of a tubey sound up front. How's that? Whatever you want to call it, it makes your pickups very hot. It makes the signal coming out of the guitar very, very hot. And the other thing it does do, it requires you to have a battery in there. If you wanted to have a true bypass switch on here, you could do that. You can actually put a switch on the guitar that takes this signal straight from there to there, or through that if you don't want the boost. But that would require you to make a hole in your guitar or something like that. I don't believe in making holes in guitars, but that's up to you. And one friend of mine wants me to do that. He's got a totally personalized guitar. It's already got a few switches on there that he had for tone shaping and for coil swapping and all that sort of thing, inverting, and he wants me to put it in the guitar like that, so that's what I'll do. You'll have a true bypass and you'll have the buffered signal as an option. Okay, now all that's left for me to do is to plug a guitar in here, plug this into an amp, put the microphone on the amp, and horrify you with the before and after. Oh, and of course, what I'm going to do is measure that resistance, and I'm going to put a fixed resistor in there. So let's just take this all out, see what resistance we have there. I believe it was about, what is it, 10 ohms, 10K? Not sure anymore. 9.2, yeah, it can be a 10K resistor, no problem. In fact, if I do this, if I give it 10K, there's capacitors involved, so let's call that 10K. If I now do the same thing, what do I get? I've got 4.9 times gain. Yep, and I've got, this thing's going to distort at, let me see, yeah, it's going to do that asymmetrical distortion up there at about 0.5 volt RMS. Good, that's exactly what I want. I decided to do this right. I decided to fit this into my lag imperator, and I may change it out later, but for a while I'm going to use hot pickups. So let me show you what I did here. First of all, I glued with hot glue the battery connector to the back of the board, and that means that I can just take the positive and pass it underneath. So that's the positive supply. The negative of the battery is going off here. These are the two outputs over here, ground and the output, and the input, which was originally the signal wire connected to the jack, is over here. There's the ground and there's the signal wire. So this thing really is as neat as can be, and it means now that I just plug in the battery. I've got no socket in here, so the battery's not going to connect. Plug in the battery like that, and then I've got a space in there to fit it into. Really fits nicely in here. Just shift these wires a bit. It actually helps to hold this battery tight in there. And this thing is as snug as can be. See that? Very snug. It's nice and tight. Even if it comes across here, it won't short because this wire is holding it back. If I wanted to, I could put something there to permanently separate it, but I just know it will not touch. And everything else has not been messed with. All I did was removed this signal wire from the jack, plugged it into the input, took the output, put it into the jack itself, and then of course that battery ground goes to the middle connector of the jack. This jack happens to be a stereo jack already, which was good for me. Sometimes you have to change them out if it's just a mono. But that's ready to test, and I'm going to do something first. I'm going to bypass the signal just on the fly to show you what it sounds like without it on, and then I'll put the battery in and I'll show you the result. That looks like a bit of a mess, but it should do the trick. Just to give you a quick demo without any effects on there. Let's see what it sounds like. I'm just going to use my line 6 amplifier. It's set to a clean guitar amp. Let me see what it sounds like. Okay, now I've got the booster in. I'm going to put the volume down low on my guitar because this thing is going really loud, quite a lot louder. volume down on the guitar, sounds pretty much like before, but if I take it up, this thing is completely different. So most of the control is actually on the guitar volume control. And there's a lot of range. Okay, I like it. Alright, that's all you're going to hear me play. There's actually a bit of reverb on the amp as well, which I should have set to 0, but never mind. I think you've got an idea of the comparison, and I can stop embarrassing myself with this atrocious playing for now. And I actually like the sound, so I'm going to leave it in. I'm going to leave this in for now. I may change my mind later, but the beauty of this is that it's pretty easily reversible. But for now, I'm going to play with my little booster. It does change the sound, even I can tell that. And it not only gives it more gain, but it does give it a bit, it's almost like it gives it a different type of sparkle. I guess those are the harmonics playing in the background there that you normally wouldn't hear. But if you want to liven up your guitar, that's it. Now this is a lag Imperator with really hot pickups. I love this guitar, I really do. It looks a lot better than I can play, but never mind. All right, that's how I'm going to leave you today. I hope you've enjoyed that, and I hope that some of you decide to go ahead and build this thing. Give it a try. It's very easy to install, very easy to reverse if you don't like it. The draw on the battery is extremely low. It's less than 1 milliamp, so that 9-volt battery will last a hell of a long time. And with the jack out of the guitar, there's no current flowing at all. So you don't have to sit and worry about changing the batteries every 2 or 3 days. So what I'm going to do next is I'm going to put the links to the share section of the PCBWay website down below. One's going to say through-hole, one's going to say SMD. Take your pick, go for it. Believe me, SMD is not as difficult to solder as you may think, especially on a small circuit like this. Very small, quite easy. And if you want to go ahead with that, enjoy. So I hope you've enjoyed that. If you have, click like, share, subscribe, and all that jazz. And if you want to support the channel directly, you can do so on Patreon and PayPal. Links are in the description below. Once again, thanks for watching. Bye for now and stay safe.